Hey everyone, Alex Williams, the New Stack here. And at AWS reInvent, we saw the intersection of three vectors in the artificial intelligence and machine learning landscape. Number one, a new generation of data clouds and intelligent applications. Number two, scalable AI ML development. And number three, chips, and more chips. Number one, data clouds are forming. Data clouds are leading to a new generation of intelligent applications. Madrona Ventures is marking this shift in intelligent apps with a new list it calls the IA40. With support from Goldman Sachs, the list represents early, mid, and late stage private companies. It also showcases technology enabling companies like Databricks and Data Robots that are empowering intelligent applications. Continuous development workflows are emerging as data gets programmed more deeply into the apps.
I think you're going to see the conceptual equivalents of things like GitLab and GitHub that are going to need to be built out on the data side. Really interesting example applied to life sciences there. A great company called Incitro just published and open source something I think they call Recon, which is a version of a data pipeline. Ultimately, those two worlds have to come together. I've built my data models, I've trained them, I think they're ready for deployment, and they're being deployed with this contextually relevant software to go solve a problem. And so I think what we can see most interestingly in the next 3 to 5 years is how those two parallel paths get built out, especially on the data pipeline side, and then how they integrate and come together and deal with issues like model drift, ongoing model learning, and improving of the models based on what we're seeing out in the real world.
Is ML Ops for real? It's happening. With services such as OctoML, it's getting easier to scale out machine learning models. OctoML is based upon Apache TVM, an end-to-end machine learning compiler framework for CPUs, GPUs, and accelerators. Apache TVM is a project originating from the University of Washington. TVM stands for Tensor Virtual Machine. It provides a common layer across targets that exposes a clean interface to the upper layers of the stack and machine learning frameworks such as TensorFlow and PyTorch.
What Apache TVM does is create a set of common primitives across all sorts of different hardware, from embedded CPUs to service CPUs, small GPUs, large GPUs, accelerators, and so on. And then it uses machine learning internally to produce efficient machine learning code. Okay, so to get a little bit meta and inception here, uses machine learning for machine learning code optimization. The reason that's important is because, by and large, today, the work done to get a model ready for deployment is manual. It involves a lot of manual software engineering to get your model ready to be deployed. And we automate that using these machine learning-based techniques.
AWS SageMaker Canvas now has that no-code, low-code capability, as does AWS Amplify.
I found what's even more interesting is trying to make machine learning more accessible. So there's a new capability on SageMaker. It's essentially a no-code ability. No code and low code is a popular trend right now in software in general. Applying that into the machine learning area, we think will be a big trend in the years ahead. And there's Amazon being out early on that with their SageMaker, Canvas offering. So I found that to be very interesting. Also, the continual, Amazon, has been working on their own versions of chipsets. They're ARM-based, and they've got, the Graviton chips, and they came out with Graviton 3. So I think there's that whole generation of chips as well that's quite interesting, because the model training is becoming increasingly specific. I choose particular frameworks. I have different data types. I want to train them on very specific types of instances at a high capacity, and that's what they're trying to enable.
Number three, chips, and more chips. The AWS Graviton chip is an example of the specialized hardware that fits both continuous development environments and AI ML workloads. The primary difference comes down to the amount of processing power being used. Lower energy costs means more savings, up to 30 to 40% savings on your computing power.
And so with Circle supporting their use of their workloads now running on ARM, they're able to build their software in a multi-architecture build in the same pipeline flows. So with one commit into their repositories, they're able to now build for Intel architecture, for ARM architecture, across the multiple form factors that they want their application to be available in and distributed in, and able to do that all in a single pipeline, as opposed to previously they would run separate solutions to try and accomplish those two things.
In conclusion, 3 themes surface at AWS reInvent. Number 1, data clouds are emerging as a middle layer on cloud services. Snowflake and services such as AWS Redshift allow for easier convergence of different data silos, leading to a new generation of intelligent applications. Number 2, AI and ML are moving from the research lab, and with it comes the first emergence of simpler ways to deploy machine learning models at scale. Number 3, a new generation of chips are emerging for compute-intensive workloads that also are being used in CI and CD environments. Thanks for watching, everyone. As usual, please like and subscribe to our YouTube channel. Follow us on your favorite social media channels, and come visit us at thenewstack.io.